So we already covered this a little bit in our earlier discussion of Lewis dot structures, but here I'm going to elaborate a little bit more about how to draw a Lewis dot structure. So the first thing you want to do is position the most electropositive atom in the middle with the more electronegative atoms around it. And if you forget where electronegativity is, I always remember that fluorine, the letter F, is the most electronegative atom. So as you head towards fluorine, you get more electronegative. Once you've positioned that central atom and the atoms around it, you want to add valence electrons. Now you want to be aware of overall molecular charge. In other words, does this molecule carry a negative charge and I need to give it a bonus electron? Does it carry a positive charge and I need to lose an electron? And you want to form bonds between the central atom and the terminal atom. Remembering that one bond uses 2 electrons, 2 bonds or a double bond uses 4 electrons, and 3 bonds or a triple bond uses 6 electrons. At this point, you want to check if it's necessary to complete the octets of terminal atoms by moving electrons out from the central atom. In other words, ensure that everybody is following the octet rule because you want to make sure that all atoms have those 8 valence electrons. Next, you calculate formal charges and add double bonds if necessary. And always do a last check. Make sure all atoms that want to follow the octet rule are. And do a last check that you have as many electrons as you came with. In the previous video, in the previous example, you saw me calculate the total number of electrons, and that was the last check I did. So make sure that you're doing that, because that's a really good way to ensure that you have a correct answer. Now, keep in mind that some atoms do not follow the octet rule. Typical atoms that are electron deficient are hydrogen, which makes sense. It only has 1 valence electron and only makes 1 bond, and boron, which makes 3 bonds. And in fact, this is true of all atoms down the boron column. So boron, aluminum, and so on are all going to be electron deficient. You'll see this becoming important when we discuss acidity. Typical atoms that can make more than 4 bonds are going to be phosphorus, which can make 5, and sulfur, which can make 6. But a really important thing to watch out for in all of organic chemistry is carbon and nitrogen can only ever make a maximum of 4 bonds. This is a really common mistake that students will make, especially with nitrogen. So ensure that they never make more than 4 bonds because that will never happen. Now, let's take a last look and draw a Lewis dot structure here for the carbonate, or CO3 2-. Let's start with determining the total number of electrons. Carbon here comes with 4 valence electrons. Each oxygen, and there's 3 of them, arrives with 6 valence electrons, and we have a grand total of 2 bonus electrons from the charge, which gets me to a grand total of 24 valence electrons. Now what I want to do is place the central atom. That's going to be carbon because it's the least electronegative and it's there in the minority. Then I'll place 3 oxygen atoms around it. Now I can start to work in the electrons. We'll start by making sure that carbon follows the octet rule. And again, we're going to have 1 double bond and 2 single bonds. Now you'll notice that carbon's following the octet. This is great news. And so we want to ensure that all the other atoms are as well. We'll put 2 electrons as lone pairs and 2 sets up there, 3 sets of lone pairs down here like so. And we'll do a quick double check. Do we have the right total number of electrons? 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, and 4. Great news. Now let's draw it with lines here next door to make sure that we're happy with it. I'll get the lone pairs on here like so. And we want to make sure to assign those formal charges. Now we know that the oxygen up top has 2 lone pairs and 2 bonds. That is neutral. Each oxygen atom here carries a -1 charge, and let's check out this carbon. It has 4 valence electrons from the periodic table, no lone pairs, and 4 bonds for an overall charge of 0. So this should give you a good feel for how to draw Lewis dot structures, remembering that they're an entrance point to some bigger ideas as we start to move towards drawing molecules in three-dimensional space.